Okay, the next topic is Bayes' theorem. Okay, Bayes' theorem is a very powerful theorem which can be used in data mining techniques. So it starts with a set of mutually exclusive and collectively exhaustive events. So that means here we have, say, k events, A1, A2, all the way through A sub k. Okay, each event are mutually exclusive. So there are no intersections, okay, among these A's. And when you take them all together, they collectively give you the sample space. All right. So we start out with our initial probabilities for these events. And these are called prior probabilities. So we have P of A sub 1, P of A sub 2, and so on. And since these are mutually exclusive and collectively exhaustive, they should all sum to 1. Okay. Now, if there is an intervening event, some other event that happens, right? So some new information is available to you, and these are called conditional probabilities. So we have event B. Okay, so that is an intervening event. Okay. We'll look at an example in just a minute. So now we have the conditional event of that intervening event given each of these prior events that we are interested in. These are the events that we are in. For example, well, let's take an example right now. So you have, say, an applicant for mortgage loan. Okay, so applicant is good, good risk or bad risk, or good risk, moderate risk, bad risk. Now the intervening event could be your credit score, right? So a credit score, well, good credit score and bad credit score. So say, let's say B stands for good credit score. So now you look at the probabilities, good credit score among bad risk, good credit score among moderate risk, good credit score among good risk. So these are the conditional probabilities. Now when you multiply these conditional probabilities with the prior probabilities, what would you get? So probability of B given A1 times probability of A1 will be the intersection probability between A1 and B. So these are called joint probabilities. Intersection, one other name for intersection is joint probability. Now when you add all these joint probabilities, what you will get is the probability of B. So it's something like this. So you have, suppose if this is the sample space, if this whole thing is the sample space, so that's A1, that's A2, and so on, A sub k. So they are mutually exclusive and collectively exhaustive. So now we have probability of B given A1. Well, this is probability of A1. So we have probability of B given A1, probability of A2, and so on. And when you multiply these two, you get that intersection. Okay. And now B has intersected with this mutually exclusive, collectively exhaustive set. So you have all possibilities of B. So when you add all of this, you get probability of B. So this, when you add this way, you get probability of B. So now if you divide that probability back into these individual joint probabilities, you would get the posterior probability. That will be probability A1 given B. So it will be given good credit report. What is the probability that the applicant is a bad risk? What is the probability that the applicant is a moderate risk? What is the probability that the applicant is a good risk? So those are called posterior probabilities. Okay. Now your textbook has arranged these columns a little bit differently, but this is the more standard way of expressing the table. So that's the theory. So now let's look at an example.